We are looking at figure 2.4 in the textbook, and this is showing unequal radiation on a sphere. So these arrows right here indicate shortwave radiation coming from the sun. And this incoming solar radiation, we have a term for, we call it insolation. So notice this is S-O-L, not S-U-L, not insolation, insolation. So this is incoming solar radiation from the sun. Now in this image, this incoming solar radiation is hitting the equator perpendicularly. So remember, perpendicular means normal to or at a 90-degree angle. So if you're looking at a surface, this horizontal surface right here, this line is running perpendicular to it, making a 90-degree right angle. Now, get rid of that. Imagine that you have a flashlight and you're shining it downward. Sorry, there's a lag here, so my flashlight is a little funny looking. But you shine it directly down onto the ground, and you're going to have a pretty dense circle of light straight below. Now, because Earth is a sphere, the light hitting the poles, so the higher latitudes, we're calling the equator, would be a latitude of 0. The North Pole would be a latitude of 90 degrees north. The South Pole would be a latitude of 90 degrees south. So the insolation hitting the poles is actually not hitting at a 90-degree angle. It's hit it's not coming in perpendicularly. It's hitting at an angle that is, I guess, smaller, if that's how you look at it. So now if you have a flashlight that you're shining on the ground at an angle that's not 90 degrees, so you're not perpendicular to the ground, then you'll notice that the light beam left behind below is going to be spread out, and it's not going to be, sorry, this thing is just going out of control, and it's not going to be as bright. It's going to be lighter looking on the ground. All right, and that's how we get unequal heating on Earth's surface, because the flux density of solar radiation, so that is watts per meter squared, so energy per time per square meter, is going to be less at the poles than it is going to be at the equator.